Good morning, students. I'm Dr. Fatima from South Institute of Research and Technology. I'm taking cathode ray oscilloscope. These are the outline of this lecture. Oscilloscope, what is an oscilloscope, how an oscilloscope works, its basic parts and operation, electrostatic focusing, material used for the screen, probes, types of the oscilloscope, and application of oscilloscope. So this is the cathode ray tube. The heart of the CRO is cathode ray tube. You see this cylindrical is the cathode. Inside of this filament is present. This is the pre-accelerating anode. This is focusing anode. This is accelerating anode. Then this is Y plate, that is vertical deflection plate. This is X plate, that is horizontal deflection plate. This cathode and accelerating anodes comes under the electron gun assembly, and Y plate and X plate comes under the deflection system. All this put in a glass tube, and this glass tube is evacuated. So vacuum glass tube is taken to place all these things, and this is the screen of the CRO. When the cathode is heated up with the help of this heating element, the cathode start emitting the electrons and moving towards the anode. Since the cathode is connected to the negative terminal of the power supply, so electrons are repelling from here, and the positive terminal of the supply is connected to the accelerating anode. So these anodes are attracting the electrons. So electrons start moving in this direction. The electrons, when electron moves inside of this the deflection plate, the electron beam start deflecting due to the field present at Y plate and deflection plates. So electron beam will be moving and going to strike on the screen of the CRO. This screen is having a coating of phosphor material. Now next, see the explanation. Here the cathodes are emitting the electrons. These circles are electron, actually considered as electrons. So these electrons are moving through the aperture of the grid. Then this a beam of electron moves through the first anode. This anode is connected to the positive potential of the supply, so electrons are attracted towards this side. Now next, the electrons will be moved towards the second anode, that is the accelerating anode, and finally the electrons will land on the screen of the CRO. So this is the complete diagram. So here the cathode is emitting the electrons. These electrons are scattered and repelled by the cathode and moving towards the anode, and then it lands on the screen of the CRT. So in this manner, the signal is displayed on the CRT. Now this is the diagram of CRT, the cathode, anode, deflection plates, and the screen of the CRO. The cathode is connected to the negative terminal of the supply. This anode is connected to the positive terminal of the supply. On the deflection plates, the input signal and the time-based signals are coming. So when electron passes through this is going to deflect and going to strike on the phosphor screen of the CRO, and this screen will display the waveform, input waveform. Now the screen of the CRT, the screen material for the CRT, the screen material is phosphor. The phosphor is coated on the screen of the CRO. You can see here there's a pic of the CRO. Here you can see this. This is showing the screen on which the signal is displayed. So the phosphor is coated actually on the glass screen. This phosphor is having the property of fluorescence. That is the property of the material to emit the light when it is stimulated by the radiation. This is called fluorescence. The fluorescent material is actually the phosphor, and it is having the property to continue emitting light even after the source of the excitation is over. This is called phosphorescence effect or phosphorescence property. This property of phosphor is used for the screen of the CRO. So because of this, when input is removed from the CRO, but this CRO is going to display the waveform for some seconds, some microseconds. Now the graticules. What do you mean by graticules? The graticules is actually the division of the uh, screen into the parts, or you can say these are the divisions of the screen. The screen is divided into the scale so that the measurement can be possible. So the easy measurement can be possible. The graticule is a part of the visual display to facilitate the measurements. So with the help of these graticules, the measurement can be done easily. The complete screen is divided into parts or into the divisions. This is one division, the second division, third division, and so on. So this one division is of 1 centimeter, and this 1 centimeter is again divided into 5 parts. So these 5 parts are showing 0.2 centimeters. So similarly on the horizontal axis and similarly on the vertical axis. So this is the screen of the CRO. See here, you can see here this screen is divided into the parts or the division. This is one division, it is equal to of 1 centimeter. This is another division, and so on. And on these divisions, the subdivisions are also done. You can see here the subdivisions are also present here. So these are the graticules. Graticules are used to measure, to do the measurements easily. Types of the graticules: external graticule and internal graticules. The scale marked from outside. So this is called external graticule, and it removes the parallax error. And the scale marked from inside of the screen. So this is called internal graticule. The internal graticule also removes the parallax error. On next slide. Now the probes are the, you can see here, this is the probe. This probe is nothing but the cable, and it is used to connect to the CRO to transmit the signal. So it is used as the feeding line, feeding the signal to the CRO. So there are two types of probes: passive probes and active probes. In passive probes, the passive elements are connected, like resistance, inductor, capacitors are connected here. So in the passive probes, only the passive elements are included. In active probes, the second type is active probe. Active probe has active components like diode, transistors. So this such type of probe is called active probe. So you can see here, this is the active probe and this is passive probe. So with the help of these probes, the signal is given to the CRO from function generator or from some circuit. Now these are the applications of the oscilloscope. The oscilloscope is used for the measurement of DC or AC voltage, or for the amplitude measurement the oscilloscope is using. For the measurement of time period and indirect measurement of the frequency can be done with the help of the oscilloscope. The pulse width can also be measured with this. Pulse rise time and fall time can also be measured. The phase difference between the two signals can be measured if it is given to the CRO simultaneously. Now next is the electrostatic focusing system of a CRT. Inside of the cathode ray tube, the electrons are focused towards the center of the CRT. So when this is the cathode, this is pre-accelerating anode, this is focusing anode, this is accelerating anode, this is a screen. So this pre-accelerating anode is connected to the potentiometer. So the high voltage supply is connected here. So the potential across this resistance, and this resistance, this much potential is provided to the pre-accelerating anode as well as to the accelerating anode. So pre-accelerating anode and accelerating anodes are connected to the same potential, and focusing anode is connected on lower potential side. So the cathode emits the electron and start moving towards the aperture, and when it enters towards the pre-accelerating anode, since this pre-accelerating anode is having more potential, more positive potential, so electrons are attracted towards this, and they are moving, but when they move towards the screen, these electrons get scattered And focusing anode is having low potential, so the electrons are not very much concise towards the center of the CRO. But when these electrons reach to the accelerating anode, now since the accelerating anode is connected to the high potential as compared to the focusing anode, so most of the electrons are attracted towards this, and most of the electrons are concise at the center of the tube. And in so these concised, these accumulated electron will be moving towards the center of the screen. So in this manner, the pre-accelerating, focusing and accelerating anode provide the electrostatic focusing to move the electron towards the center of the screen. So this is called electrostatic focusing system. Now there are two types of focusing system. There are two types of deflection system: magnetic deflection system and electrostatic deflection system. In magnetic deflection system, the deflection is done for a very short period of time. It is employed in low frequency region, but this consumes more power. Whereas electrostatic deflection, this deflect the electron beam for a long period. This employed in high frequency region, and also it consumes less power. So that electrostatic deflection can be used in the CRO. Now next, I want to talk about the types of the oscilloscope: analog oscilloscope and digital oscilloscope. The analog oscilloscope techniques is used to create the pattern on the display. Now, like you can see here, this is the analog CRO. Now, this digital oscilloscope first converts the signal into digital format and then process it. So, this picture is showing the digital oscilloscope. So, the sine wave, square wave, or any type of wave you can display on this. But the digital oscilloscope is also having the memory. It stores the signal, and for the calculation purpose, when cursor moves on any point of the waveform, the digital oscilloscope gives the value in digital form, whereas in the analog oscilloscope, we have to do the measurements. It will not be available on the screen, but in the digital oscilloscope, the values or the measurements are readily available. Now, the advantages, like analog oscilloscope is less expensive and it is having good level of performance. The digital oscilloscope, it is having display storage. So whatever the signal is displayed, it can be stored. This is having high accuracy, brighter display, and self-calibration. So different types of digital oscilloscope: digital storage oscilloscope, digital phosphor oscilloscope, digital sampling oscilloscope, mixed domain oscilloscope, mixed signal oscilloscope. So these are the types of the digital oscilloscope. So these are the books: David A. Bell, Electronic Instrumentation and Measurements by David A. Bell, Electronic Instrumentation and Measurements by William D. Cooper, Electronic Instrumentation by H.S. Kelsey. So you can refer these books for the CRO. Thank you, friends. Thank you so much. See you again. Bye.